Hello everybody, welcome to Unit 2, Lesson 11, and this is just a video full of Half-Life example problems. So hopefully at the end of this video, you understand how to answer different types of questions that involve Half-Life. Our objectives. So our objectives for this video is to understand how long it takes for unstable nuclide to decay by using Half-Life by working through different types of example problems. Our first example, if you start with a 120-gram sample of radium, how much will you have left after 44 days? So we know by looking at this right box over here, radium has a half-life of 11 days. So that means for every 11 days, you're going to have exactly half of the amount of radium that you started with. So if you look down over here, if we initially start with 120 grams, exactly 11 days later, we are going to end up with 60 grams now of radium. And we want to figure out how much would be left after 44 days. So if each half-life is 11 days, we know that we have to complete 4 half-lives in order to solve this problem, because each half-life is 11. 11 times 4 equals 44. So we are going to go through 4 half-lives, and you can see each box represents a half-life. So this is our first one, second one, third one, and then fourth one, until we get to our final answer of how much radium will be left. So initially we started with 120 grams, half of that would be 60. All right, going from 60, having 60 grams, exactly 11 days later we will have half, which will be 30 grams. Another 11 days went by, and then we end up with 15 grams of radium. And then lastly, 11 more days passed by, and we have left 7.5 grams of radium. And this would be our answer, 7.5. That's how much radium we will have after 44 days. If you look at the bottom, sometimes the answer asks you to calculate what percentage of radium will you have left after 44 days. So the way that you can calculate this is we can think of our graph from our previous video. We know initially we are going to say that we are starting with 100% of our sample of radium, and going from here to here, we're going to end up with 50%, because it's exactly half of what we started with. And then from here to here, we're going to 25%, and then here to here, we see half of 25 is 12.5%, and then half of 12.5 is 6.25%. So to answer this question, what percent of radium do we have left? We have 6.25% of radium left after 44 days. Let's work through another example problem. An 80-gram sample of tritium decays, leaving 2.5 grams of tritium. How long will this take? And if you look at the right, we know tritium has a half-life of 12.3 years. Now, this one is going to decay exactly half in years. So we are starting with 80 grams of tritium, and it's going to decay and undergo a half-life, which is going to take 12.3 years. And we know that we have to end up with 2.5 grams of tritium. So we're just going to go through this process and keep cutting our initial amount in half until we get to a final answer of 2.5. Right, and if we see this, half of 80 is 40, so we're going to put 40 over here. All right, then this 40 grams, after another 12.3 years, we're going to have half of 40, which is going to be 20 now. Half of 20 is 10, and that also took to 12.3 years. Another 12.3 years went by, and we have 5 grams of our tritium, and then our 5 grams after 12.3 years, we have exactly half, which is now 2.5 grams of our tritium, and that's what our answer is. So how long does this take? So what we're going to do in order to calculate how long this will take, all you have to do is take 12.3 years and then multiply that by how many half-lives you completed. So in this, we completed 1, 2, 3, 4, 5 half-lives. So it will be 12.3 times 5. And the answer to this is 61.5 years. And this would be our final answer. If we wanted to put this in percentage form, you can see at the bottom how many half-lives will leave 3.1% of hydrogen. All you have to do in order to calculate this is know that our initial amount is going to be 100%. Okay, and going from 100 to our first half-life, we're going to end up with 50%. From that to that, we're going to end up with 25%. We're trying to do as many half-lives as we can in order to get a final answer of 3.1%. So half of 25 is 12.5%, and then half of 12.5 is 6.25%, until we finally divide 6.25 in half and we get 3.125%, and that would be our answer. So how many half-lives would it take for us to end up with 3.1% of hydrogen? And we just count 1, 2, 3, 4, 5, 6, and that answer would be we need to undergo 6 half-lives in order to get 3.1% of hydrogen left. Last sample problem. You start with 200 grams of thallium-206. After 20 minutes, there is only 12.5 grams of thallium left. What is the half-life of the decay process? And if you see at the bottom right here, we don't know what the half-life is, but we can calculate for that because we know 20 minutes go by and there is only 12.5 grams of thallium left. So our total amount over here, total time that elapsed, was 20 minutes. And we end up with 12.5 grams of thallium. So we can start by doing our half-lives. We know half of 200 is 100 grams. Half of 100, if it undergoes half-life, is 50. Half of 50 is 25 grams, and then half of 25 is what we have left in the problem, which is 12.5 grams of thallium. So if this entire process took 20 minutes, we want to figure out what is or how long it takes for us to just undergo one half-life. So how many half-lives did we calculate for? 1, 2, 3, 4. So we underwent 4 half-lives. In order to calculate how long it would take for one half-life, we know that 4 half-lives is going to take us 20 minutes. So all we need to do is take 20 minutes and divide it by 4, and we get a final answer of 5 minutes. And what that means is going from here to here is going to take 5 minutes. And then from here to here is going to take another 5 minutes. And we can check our answer by just calculating 5, 5, 5. And that does give us 20 minutes. And that is the end of this video. I hope this helps in order to solve different half-life problems. Thank you, and let me know if you have any questions.